Hello everyone. This is the third video of units and dimensions. In this video, let us see what are fundamental units. Fundamental units. So, what are fundamental units? The units of fundamental quantities. The units of fundamental quantities are called fundamental units. Fundamental units. In SI, fundamental units are as follows. Let us see what are these fundamental units. We have fundamental quantity length, its unit is meter, symbol is small m. Fundamental quantity is mass, its unit is kilogram, symbol is small k, small g. Fundamental quantity time, its unit second, symbol is small s. Fundamental quantity is strength of electric current, unit is ampere, symbol is capital A. Fundamental quantity thermodynamic temperature, unit is Kelvin, symbol is capital K. Fundamental quantity amount of substance, unit is mole, symbol is small mol. The last fundamental quantity is luminous intensity, its unit is candela, symbol is CD. So just you remember how we wrote symbols here, because later while discussing rules to write SI units, we may come across again the symbols which we are using here, right? Let us see fundamental units in some of the old systems. What is that? Fundamental units. Fundamental units in some of the old systems. So what are that old system? One is FPS, next is CGS, next is MKS. And fundamental quantities are here: length, mass, time. In FPS, length is measured in foot, mass is measured in pound, time is measured in second. In CGS system, length is measured in centimeter, mass in gram, time in second. And in MKS system, length is measured in meter, mass in kilogram, time in second. Let us see what are supplementary units. Supplementary units. So what are supplementary units? The units of supplementary quantities. The units of supplementary quantities are called supplementary units. So we have learned supplementary quantities. They are plane angle, solid angle. So unit of plane angle is radian and symbol is RAD. And unit of solid angle is radian, symbol is SR. Now let us see what are derived units. Derived units. The units of derived quantities. The units of derived quantities are called derived units. So let us see SI units of some of the derived quantities. So first derived quantity is area, and its SI unit is meter square. Volume, its SI unit is meter cube. Velocity, its SI unit is meter per second. Force, its SI unit is kilogram meter per second square or Newton. Energy, its SI unit is kilogram meter square per second square or joule. So now let us see rules for writing units in SI. Rules for writing units in SI. So there are certain rules in physics while writing units. It's not our wish to write units. Let us see what are those rules in writing units. Okay, so let's see rule 1. All the symbols of fundamental units, all the symbols of fundamental units should be written as they appear in the table of SI unit. In the table of SI unit. So let's see what is the table of SI unit. Just now we have discussed table of SI unit. So this is the table of SI unit. Here length is represented with a unit called meter and its symbol is small m. Mass, its unit is kilogram and symbol is small k small g. Time has a unit second, its symbol is small s. Likewise, strength of electric current, ampere, its symbol of unit is capital A. Capital K is for Kelvin, MOL is for mole, CD is for candela, right? So just we have discussed first rule, that is all the symbols of fundamental units should be written as they appear in the table of SI unit. Let's take example for this. Example, meter has a symbol M. Kilogram has a symbol kg and second has a symbol s. If a unit is represented like this, 5 capital M, 5 meter, the length of an object is suppose 5 meter. This sort of representation is wrong. How it should be represented? 5 small m. This is the correct way of writing units in SI. Let us see rule 2. In compound units, all the symbols of the fundamental units should be written as they appear in the table. As they appear in the table of SI unit. SI unit. So compound unit means more than 1 units for a physical quantity. Let's take example to understand this. Example, unit for force. So unit of force is what? It's a compound unit. What is that? Kilogram meter per second square. So this sort of representing unit is wrong. And what is the correct form of representing? Kilogram meter per second square. So this is the correct form of representing a unit, as we have used in the table of SI unit. What is the standard symbol we have used? That symbols we are supposed to use here. Like we have a unit for velocity, meter per second. Some students will represent that as meter as mt per second as SEC, which is the wrong format of writing unit. It must be represented as meter per second. So this is the correct format of representing a compound unit. So this is rule 2. Let's see what is rule 3. Rule 3. So according to rule 3, generally we will use some of the units by the names of scientists as an honor for their research in respective fields, right? Some of the units are represented by the names of the scientists, right? To honor those scientists for their research in the respective fields. Okay, so here the rule is the full name, the full name of such units of such units should be written with a lower initial letter. Lower initial letter. So let us take an example to understand this. Generally in English, proper noun is started with a capital letter. But here, when we are using name of a scientist as a unit for a physical quantity, and when we are writing its full name, the first letter must not be a capital. It must be a lower initial letter, like Newton. It's a unit of force. So starting letter is a lower initial letter. Next is joule, which is the unit of work and energy. And next watt, which is a unit of power. Ampere, unit of strength of electric current. Kelvin, it's a unit of temperature. All these units, they are starting with a lower initial letter, and it must not be written like a force of 200 newtons is exerted on a body. So you must not write 200 Newton, which is a wrong method of representing. It must be represented as 200 Newton. This is correct method. Let's take another example. 500 joules of work is done. 500 joules of work is done. This is wrong method of writing because J is capital here. The correct method is 500 joule. This is the correct method of writing a unit. Let's see rule 4. So fourth rule is The symbol of the unit, the symbol of the unit named after a scientist, named after a scientist should always be written with the capital letter, with the capital letter. So here, if we are writing symbol of the unit which is named after a scientist, then it must be written with a capital letter. Let's take an example. So symbol of unit named after scientists like Newton, symbol is capital N. Joule, symbol is capital J. Watt, symbol is capital W. Ampere, capital A. Kelvin, capital K. So etc. So if we are writing it as 50 newtons of force is applied on a body, it should not be 50 N. This is the wrong method of representing. It should be 50 capital N. It is the correct method. Like 300 joules of work done. 300 joules, small j. This is the wrong method. It should be represented as 300 capital J. This is the correct method. Let us see next rule. Rule 5. Punctuations like full stop, full stop, comma, etc. should not be used, should not be used after the symbol of unit. After the symbol of unit. Let's take an example. Example 5 seconds. 5 seconds. You must not keep any full stop after this. This is the wrong method of representing. Generally write 5 seconds. This is the correct method. So there must not be any punctuation marks after writing the unit. Okay. So let us see next rule. Sixth one. A unit should always be a unit should always be represented in a singular form. In a singular form. So we must not use any plural form for a unit. Example 5 kilograms. We will read 5 kilograms, but we must not write kgs. It should be written as 5 kilogram, kg. This is the correct way. Right? 100 meters. Some students will write 100 meters as MTS, 100 meters. This is the wrong way of representing. You have to write it as 100 meter. This is the correct way of representing a unit in singular form. So in this video we have discussed fundamental units, supplementary units, derived units, and rules for writing units in SI. Hope you have understood this video. Thank you.